A few years ago, I was hired to work on a successful product, and this product had a number of characteristics in common with other successful products. For one, the team was finding it increasingly difficult to make changes. Over the years, the product had accumulated a lot of features, and in support of all of these features, there was a lot of code. And there were no tests. The company wanted to develop a culture of testing. And they wanted this for all of the usual reasons. Shipping faster, not being terrified while you're deploying, that sort of thing. And I was brought onto the team because of a 90-minute rant that I'd had about testing and refactoring. So there I was in a language that I didn't know, in a code base that I had no possible way of understanding. And I was going to help them get this thing under test. And I quickly discovered that I did not have the skills necessary to do that. I couldn't get any part of the application under test. Every single piece of the application seemed to depend on every other piece of the application. And I couldn't get the whole application loading in a test harness because of reasons that I didn't I just didn't understand. So every once in a while, I'd come across a tiny opportunity for refactoring, and I'd extract a 30-something line long class, and it would be completely understandable and completely test covered, only to realize that the old class that used to be 3,500 lines long was now 3,500 lines long. I didn't know how to tackle the problem head on, and I couldn't figure out how to develop the skills necessary to do so. So I'm going to borrow a story from a different industry. Tony Plog is an internationally renowned trumpet virtuoso. I was told about a masterclass that he ran a few years ago for professional soloists. And so the first part of the class was very, very typical. The students played breathtakingly complex pieces, and then Tony would offer suggestions for improvement. Once everyone had played, Tony asked them to play a very simple warm-up exercise, something that might be given to any beginning trumpet student. And so each student played the exercise in turn and compared to the dramatic pieces that they had just played. This sounded childish. After everyone had taken their turn, Tony picked up his trumpet and played the exercise, and when he played it, it didn't sound childish. It sounded exquisite. Every note was deep and rich and beautiful, and he had taken this handful of notes and turned it into something elegant and graceful. The contrast between Tony's performance and that of the students was astonishing. There was a profound difference between the true master and the skilled practitioner, and that difference occurred at a fundamental level. It had nothing to do with intricate and sophisticated complexity. Tony suggested that the advanced student should spend a lot more time focusing on practicing simple pieces intensely. And so I'd like to bring Tony's lesson back into our industry using a completely spurious exercise that I made up about a year ago. It wasn't meant to teach anything, it was just a warm-up. So, meet Bob. He's 15 years old. He is not very bright, and he has an attitude problem. No matter what you say to him, he will respond in one of 4 ways. And all of this has been encoded into a test suite. And if you've been programming for, I don't know, say about 10 days or so, you should have absolutely no problem getting the test suite to pass. Now, because this is natural language, there are ambiguities. For example, because something contains a question mark, it doesn't mean that it's actually a question. You can shout without using an exclamation mark, and the presence of an exclamation mark doesn't actually make something shouting. And also, questions can be shouted. Numbers are particularly interesting because they don't have upper and lowercase variants, and this goes on. And as the complexity of the test suite increased, so did the complexity of the solutions. And I found myself adding more and more edge cases, trying to force the solutions to become simpler and more correct. So in the past year, about 2,000 people have written code to make this test suite pass. And some of these people are complete beginners, and others have been programming for several decades, and then you have everything in between. Now there are a lot of very interesting and absolutely completely valid solutions to this problem. And I'm going to show you 16 typical iterations through the exercise. So these are things that I've seen people do over and over again. This is a fairly classic starting point for someone who has never programmed before. And let me just say this, it passes all the tests. Laboriously. Sandy Metz talks about something that she calls the squint test. And it works like this. You lean back and you squint your eyes and you look for changes in shape and changes in color. So both of these things tend to represent changes in levels of abstraction. So that's not really the case here because the solution is white space challenged. Look at the vertical white space. Look at the pattern created by the indentation. And look at the inline horizontal white space. So cleaning up all of the white space gives the code a clear rhythm, but it still looks long. It's overwhelmed by the conditional. On the other hand, now new patterns begin to emerge. So the first lesson that this pointless exercise taught me is that white space is meaningful. Inconsistent indentation tends to suggest that I have a bug, or at the very least, a syntax problem. I use white space to make like things alike and to make different things stand out. And I rely on it a lot more than I was aware. So this is the code that we ended up with in the previous iteration. It has a cadence, a rhythm. Squint at it. Notice the repeating patterns. The return keyword is repeated unnecessarily, and the comparison to input happens over and over. So we can delete the returns and replace the if statement with a case statement, and the program suddenly feels lighter. And when you minimize boilerplate, the shape of the code becomes more pronounced. It highlights the bones of your story. And often this also reveals flaws and weaknesses. Notice how obvious the duplication has become now that the cruft has been removed. Each of the 4 responses that Bob has is repeated over and over again. And now it turns out that there's a very simple solution to this. And I'll have to admit that this honestly never occurred to me. So one of the first lessons that we teach new programmers is don't repeat yourself. If you don't know what else to do, removing duplication is a reasonable first step. It's easy. It's insidiously easy. We often reduce superficial bits of duplication that turn out to not be the same idea at all. And so Brian Helmkamp, who makes Code Climate, calls this chafe. It's too dry, so it chafes. Now, if you've removed duplication to the point of chafe, it's often really hard to move forward. And so if you can't figure out where to go next, try reintroducing the duplication to see if something else occurs to you. All right, so we have code that passes all the tests. It's consistent. It has no unnecessary boilerplate. It has no duplication. It does have very long lines, but we can totally rearrange that to have it on one screen. There is a problem here, and that's that this code is very, very brittle. It doesn't solve the general case of saying nothing, or asking questions, or shouting. And anything that is none of the above is listed as a specific but completely arbitrary list of statements. And so this is a great test suite if we're developing a talking toy that has a very small set of specific responses. But for ambiguous language, like conversation, adding a test case is going to cause the test suite to fail. So what we need to do is detect the rules and then provide responses based on those rules. And not based on specific pieces of input. And very often that'll look something like this. We have 3 rules, and we have some default. It's not always all that easy to find the underlying abstraction. And one of the best analogies that I have for this is, and I do apologize, deer hunting. I have a sister who has spent the last 20 or so years in Alaska, and the way that her family puts food on the table is they go out into nature and they kill it. So every fall they hunt approximately a freezer full of deer. And my sister and her husband have wildly different strategies when it comes to partitioning deer. So he brings a chainsaw. She brings a 3.5-inch Victorinox paring knife. Now, a chainsaw is very, very effective. Turns out also not ideal because blood and guts and bone fragments and your steaks and all of that. A small blade is perfect, provided that you know where the seams in the deer are, because you have to edge through the deer in all the right places and loosen it up and stick the point in the joints and kind of pop things out. And then the deer kind of falls apart, right? It's harder than using a chainsaw, but the effort involved is not ridiculous, and the trade-off is worth it. So in your programs, getting the abstractions right, or rather getting the abstractions wrong, is a lot like taking a chainsaw to a deer. It gets the job done, but it's very, very messy. And if you get them right, the code can feel obvious. It's like there's no other way that this could have been done. So we've removed duplication. We ended up with a solution that looks like Ruby. It's not too long. It solves the general problem that the README describes. And the thing that I don't like about this solution is that it's a bit irregular. It doesn't feel smooth. For example, the regexes are not overly complicated, but they're also not obvious. So rather than thinking about this in absolute terms, finding the pattern that defines what all caps means, think about it in relative terms. A string that is already all caps won't change if you upcase it. Now, unfortunately, this doesn't work for things like phone numbers. A phone number is not going to change when you upcase it, but it's not really all caps either. Now, with a phone number, it won't change when you upcase it, but it also won't change when you downcase it. It's just not caseable. So a legitimate all-caps string is a caseable string that's already upcase. So determining whether or not something ends with a question mark, this thing is doing too much. There's a string method that does exactly what you need. And lastly, comparing a string to an empty string is totally valid, but if you're going to be all Ruby about it, you just want to ask the string itself. The ability to express an idea without having to think about how you're going to express it is known as fluency. And it's the thing that lets you say more with less. Fluency is a pretty big deal, but it starts very, very small by paying attention to the tiniest building blocks of your language. And so here, finally, we have a solution that smells like Ruby. It kind of reads like English. But there's a problem, and that's the AND operator. It's supposed to be used for control flow. And we've confounded this with the double ampersand, which is a Boolean operator. So a Boolean expression asks a question, and control flow is a lot more of an imperative thing. And these are not the same thing. So our Englishy phrase is a Boolean expression. It should use a double ampersand. There's a distinction between simple and easy. And Rich Hickey describes the distinction between simple and easy like this. Easy is familiar. It's close at hand. Whereas simple is the opposite of complex. And so complex is defined as something that has many interleaved parts. It's something that's braided or tangled. So a single string tied in a knot is complex, and 100 strings hanging straight down is simple. So this is short. It's straightforward. It's idiomatic Ruby. I'm not convinced that we should be using early returns. An early return says, if this thing happens, then just get the hell out of here. Do not pass go, do not collect $200, yada, yada. Whatever you do not continue executing the code in this method. And that's not what we have here. We don't have a do not pass, go, all of that, we have 4 roughly equivalent options. It's difficult to find a balance between expressive and succinct. Too many words, and you lose sight of the meaning, and too few, and meaning is lost or distorted. So, what if you'd never seen the README? How obvious would all this upcase, downcase stuff be? And wouldn't it be helpful if these concepts could be named so that they're easier to understand? So what people often reach for is something like this. All caps, question, empty, and this hides the fiddly bits and makes the concepts explicit. But it also feels lopsided. The methods are at different levels of abstraction. All caps and empty are about strings. Question is about conversations. And ideally, all 3 methods should be about the concept of conversation, not strings. And in terms of conversation, all caps really is a yell or a shout. And empty is more like silence. And that puts all 3 methods at the same level of abstraction. It makes them symmetrical. They tell a story about a conversation, not a story about the underlying implementation, which just happens to be strings. Kent Beck suggests in Smalltalk Best Practices that implementation details, even if that implementation is a single line of code, should be hidden behind a method with an intention-revealing name. And now, that's kind of tricky, because what does intention-revealing even mean? Like, it doesn't mean anything except for within the context of what you're trying to do. So yeah, I hate this. Let's talk about Bob's API. We've got the Hey Bob method, the Bob Are You Silence method, the Bob Are You a Question method, and Bob Are You a Shout method. Right? This is a terrible API. And we can make it a little less heinous by adding a private declaration. A public API narrates a story. It's from someone's perspective. It's important that that point of view is consistent and that the story that is told is making sense to the reader. So it's still pretty awful for a number of reasons. I'm not happy about referring to the instance variable directly everywhere, because then I'm stuck to it. There's no indirection. There's no seam where I can change things without touching the code itself. And in philosophical terms, I don't want to make a distinction between data and messages. If everything is an object, then surely there's a message I can send to it to make it do what I want. And if there isn't, well, then it's my job to make it so. So this code still has a huge, huge flaw. Imagine that we have an instance of Bob, and Alice shouts, "Are you crazy?" And Bob saves Alice's statement, and at almost the same time, Charlie says, "You're late," which Bob dutifully tucks away into his instance variable, and now Bob needs to respond to Alice. He checks the contents of the instance variable, which now contains Charlie's statement, and he responds. So in other words, we've introduced a potential race condition. We need to pass the input to the helper method so that they can handle it directly. And you might argue that protecting Bob against race conditions is excessive. It's over-engineering. Bob is simple. The computations are blazingly fast. They're trivial. It's hardly likely that such a race condition should ever occur. And even if it did, so what? Bob's not very bright. It's totally believable that he would be confused if more than one person is talking to him at the same time. And ultimately, Bob is irrelevant. The most important thing here is that you don't want to save ephemeral data in an instance variable. So we've gotten rid of the race conditions by using some fancy case statement shenanigans where you can pass a proc that gets evaluated with the input. And so we have these predicate methods. And predicate methods, by definition, need to return true or false, or at the very least, something truthy or falsy. And of course, in Ruby, everything is truthy or falsy. And the only problem here is that a proc, no matter what the block evaluates to, is always truthy. So if someone were to use any of these private methods in a different situation, everything would go pear-shaped. So we need to pass the argument to the method rather than to the proc. Idioms are a bargain, and you had better keep it. To quote Dr. Seuss, say what you mean and mean what you say. Now, it bothers me that I have to pass the same argument everywhere. Not only do the private methods all have the same parameter, but the body of those methods operate only on the argument, not on anything within Bob. And this is called feature envy. The experts say that the thing to do is to move those things to the thing that they are being called on. So I'm going to do that. But before that, I totally did it right there. So before I did that, Bob had too many responsibilities. And now he's very cohesive. A highly cohesive object will have very few reasons to change. It will be a whole lot easier to understand Bob and therefore use him. Now, we do have a problem in string. String used to be all about stringish stuff. Now suddenly we've expanded its API to be about things that are at a completely different level of abstraction. So maybe the feature envy wasn't envying string, maybe it was envying some missing object in the system. And the object represents input, so maybe that's what it should be named. By moving the private methods out of Bob and into string, we made Bob more cohesive at the expense of string. If I monkey patch string, I want it to be with stringish behavior, not conversation-ish behavior. And so that raises the question, how cohesive is the new input object? And it turns out not very. It had inherited a ton of stringish behavior, which it really doesn't need, and that's not the only problem here. Inheriting from core types in Ruby can be a little bit problematic. So imagine for a moment that you have a dazzling string. It expands string behavior very, very slightly, making it possible for strings to have ASCII sparkles, a noble pursuit. And so given a unicorn string, it can sparkle, and it still has all the capabilities of a regular string, so you can upcase it, or you can pluralize it, and you have many unicorns, and all of those unicorns can sparkle. And now, imagine that you have two dazzling strings, a unicorn and a rainbow. And so they can sparkle, as one would expect. You can add them together, just like if they had been regular strings, and then you can ask the resulting unicorn rainbow to sparkle, and it blows up. Because the thing that you get back is not a dazzling string, it's a string. So we really don't have any reason to inherit from string. Let's go ahead and create a freestanding object. Now we had to add an initialize method, but the trade-off is that the object's API is now only the methods that we care about, not the methods that we care about plus 100 more that came out of string. I was working through Wake and Rutherford's refactoring workbook a couple years ago, and my mind was blown when they pointed to a 3-line method and said that it was too long. I was like, too long? How is a 3-line method too long? And it turned out they were right. I was wrong. Not because 3 lines are too much, but because those 3 lines were doing too many disparate things. So ask yourself, if this thing that I have, this method or this object, were 2 different things, what would they be? And if you can come up with some sort of answer that's plausible, not too far-fetched, then maybe your object or method has too many responsibilities. So now I'm starting to like the code. But there's one thing in particular that rubs me the wrong way, and it's the name input. Input is named at the wrong level of abstraction. It describes the role of this thing in terms of the program. It's input to a method. So we start out with string. That's more or less the lowest level of abstraction that you can have, defining the thing in terms of the underlying data structure. And then we moved up a level abstraction to input, which is the role of the thing in terms of the computation. And both of these things are about the solution, not about the problem. If you go up one more level of abstraction, you end up talking about the thing in terms of its job. It analyzes, or it parses, or it classifies. Now, none of these things tell us why we're actually analyzing, or what we're analyzing, or parsing, or classifying. So if you go to an even higher level of abstraction, you start talking about Bob's conversation itself. And in Bob's interaction, the object is a message or a comment or a statement, or if you ask the thesaurus, it's an utterance. And these have a fairly neutral feel to them. But you could really get into telling the story of Bob and say that to Bob, these things feel like a confrontation, or drivel, or blathering. So another take on this would be to say that it doesn't really represent the actual thing that's being said, but Bob's interpretation of what is being said, or the tone, what he thinks the tone is, or his perception of the interaction. And if you get into these point of view names, then of course you have to change the methods themselves, because now they have to be named from Bob's point of view as freaking out, or dumb question, or cold shoulder. It's all a matter of which story you're trying to tell. Now I kind of like remark, because it doesn't have all the drama that the other names have. It's an accurate representation of what the object is. So yeah, I heard you like remarks, so I put some remarks in your remark. I see this kind of echo all the time. For example, this is a controller I was refactoring a couple years ago. Worse, I found myself actually typing member.member.member. It was in a command line app that I'd written from scratch. And it wasn't until I found myself typing this that I realized what corner I had painted myself into, and I had to start rewriting it from scratch to paint myself back out of it. I had gotten the abstractions just slightly wrong. Dear chainsaw. And it's a slippery slope. I saw this one. It wasn't Ruby, so maybe that's okay. So back to remark. A decent compromise is to use text. It's boring, but it's safe. So every time I find myself trying to name things, I realize yet again that naming is hard. And there's no trick that you can learn. There's no rule that you can follow. I use the thesaurus extensively, and I think very, very hard about whose voice the narrative is being told from. And I'm still really terrible at it. I started working on one of these toy problems, these practice problems, in June of last year. And it's a problem that I find difficult, and so I pull it up fairly regularly and reprogram it. And I've spent a number of weekends just redoing this stupid little toy program. And I was really unhappy with one of the names that I'd come up with for one of the concepts. And then one day in December, so 6 months later, I was in the middle of a conversation and I realized exactly what it should be called. It was the perfect name. But it took me like 6 months to find it. So this is the final solution. It's far from the only good solution to Bob, but it's a perfectly good one. And it grew out of the initial code that was submitted, one refactoring at a time. So these are some of the lessons that I've learned from a warm-up exercise intended to teach nothing. And ultimately, this is about asking questions in order to challenge yourself, challenge your understanding. Assume that you got something wrong, and then figure out what that was. What bothers me about this code and why is a very different question from how might this code change in the future? I'm not making predictions about the future, because invariably when I do that, I'm wrong and it's expensive and painful for everyone. I'm trying to discover how the code that I have today can be simpler or more expressive. Thank you.